Right, teacher Jerry here. Today now is a part two of the kinetic particle theory, which mainly talk about diffusion. Right, this diffusion is mainly for the pure chem. Those who got these notes right in the PDF, you can see that all highlighted in red are mainly for the pure chemistry. So we talk about diffusion. So diffusion, very simple. I think you may have learned in lower sec is the movement from a higher concentration to lower concentration. Right. I mean, that is why durian are not allowed to be on the bus or on public transport or public space because diffusion. Right. If today the smell won't diffuse, won't move, then technically it's okay. That means the smell won't spread to other place. So diffusion, in fact, is a evidence to show that actually particles are all in constant motion. All right. That's why we talk about kinetic particle theory. It's just that just now we mentioned when we learn solid liquid gas, it's just either whether they are vibrating in fixed position or whether they are sliding over one another or when they move freely rapidly in the gas. Right, so diffusion only based on two factors. One is relative molecular mass. So later there will be a topic on the MR, we will calculate it. So technically we can think in common sense that the lighter person it is, the faster you will move. And of course temperature. By now we understand that when you increase temperature, kinetic energy will increase. Right? This is always correlated. All right. So just imagine that, of course, now you're in a hot room, then you won't be able to sit still. You will start to move around for the moving air. So your kinetic energy increase. So a typical questions can be like this. All right. Gas A. So take note that outside here is your gas A. So gas A want to go in, and the gas B want to come out. As long as there's a region of higher concentration, it would particle will move it to a higher to a lower. It's only how fast or how slow. Right. So in fact, diffusion do also happen in solid liquid, but that's like so slow that we cannot even notice it. All right. So that's why we talk about gas. All right. In this case, okay, we compare the MR. See, if let's say they are gas A, if gas A has a higher MR, then so you'll be slower, is it? So in the end, there will be more gas coming out. Right. There will be lesser gas, and therefore you exert pressure, lesser pressure here, the X will increase. And we use this similar thinking to when you have a lower MR, right? Then of course it will diffuse faster, right? Therefore, there will be more gas going in than the gas coming out. Just imagine that if let's say every time two-person come in, one-person go out, two-person come in, one-person go out. In the end, there will be more gas in the porous, you exert more pressure, and this X will go down. All right, pushing the X will be down because whatever that is here is air pressure, is by the air. So it won't change. What changes is only here due to the rate of the diffusion. All right. And of course, if the same MR, if you make a guess, they will not, the level X will not change at all. Because imagine one person go up, one person come in. Every time one person go up, one person come in, the number of gas is the same. So the pressure will be the same. All right. That will be for your diffusion. See you in the next chapter. Thank you.